Welcome to Coinly YouTube channel, your #1 channel for tech and blockchain education. Last time on Blockchain for Beginners, we discussed the definition and pointed out some of the most important blockchain components. Don't forget that we divided this into series to ensure that you fully understand every little thing about blockchain. And today, we will be focusing on the types of blockchain, how blockchain transaction works, and how blockchain secure each transaction. However, if you have not watched the previous series of Blockchain for Beginners, kindly do that right after this video, or even before you watch this video. We put in a lot of work to make this video. So, please like this video and subscribe to our channel. Don't forget to share this video with your friends who would like to learn more about blockchain. Also, please turn on your notification so that you can get notified each time we post our video. Guys, let's get to it. Blockchain is an interesting technology. However, there are different types of blockchain, and users leverage this technology for many use cases depending on its type. Therefore, that call for different types of blockchain. The first is the public blockchains. Blockchains facilitate a decentralized, open network of multiple computers that anyone can access to request or verify a transaction for accuracy. It allows users to create new blocks, accesses all the blocks in the blockchain, and validate the data. As they are open and need excellent security, they use concepts like proof of stake or proof of work. The block miners who validate transactions are rewarded financially. Public blockchains are mainly used for mining and exchanging cryptocurrencies. Example of that includes Bitcoin, Litecoin, and Ethereum blockchains. The second is the private blockchains. Private blockchains are centralized and governed by a person or organization that decides who can access the blockchain, be added as a node, and verify records. Unlike public blockchains, private blockchains aren't open and offer access restrictions. If anyone wants to join a private blockchain, they must obtain permission from the administrator. An example of this is the B2B virtual currency exchanges like Hyperledger. The third is the consortium blockchains. A group of companies or organizations govern these permission blockchains instead of one individual. They are more decentralized than a private blockchain to enjoy more security. It allows limited access and the present nodes determine the consensus process. Furthermore, it constitutes a validator node to initiate, receive, and verify transactions, while member nodes have permission to initiate or accept transactions. Here, users can transfer digital assets with improved efficiency and scalability from one blockchain to another. An example of this type of blockchain is consortium blockchains used in payments and banking, such as Quorum and Corda. The fourth one is hybrid blockchain. Hybrid blockchains combine the attributes of private and public blockchains. They can be centralized or decentralized and allow organizations to set up a permission-based private blockchain along with a public blockchain. This implies that the organizations can control the data access in the blockchain and what data to access publicly. It's used in real estate and retail industries, such as IBM Food Trust. Now let's look into how a blockchain transaction works. Step 1. Transaction request. First, an individual requests a transaction that might involve real estate, banking, cryptocurrency, records, contracts, etc. For simplicity, let's assume that the transaction is cryptocurrency. Step 2. Distribution. The transaction requested gets broadcasted in the peer-to-peer network through nodes located across the globe. Step 3. Validation. The nodes in the network validate the transaction using algorithms and solving complex equations. If they find the transaction legitimate, the records are entered inside blocks. Step 4. Adding blocks to the blockchain. After the transaction completes, the newly created block is chained with the previous block with cryptography and encryption. It has a hash code and contains the hash code of the previous block. Once this block has filled its allocated space, the next block starts filling and attaching to the previous block, hence a long chain of transactions is formed. This is immutable and transparent for everyone in the blockchain. If you are yet to like this video, kindly hit that like button and subscribe to our channel. Thank you. Most people get worried about the security of blockchain if all the process is very visible to everyone. However, it is actually secured, and here is how blockchain makes sure of that. The first one is immutability. Immutability in blockchain means no one can manipulate data entered in the blockchain. It's because every block has a unique hash code and another referencing the previous block. The cryptographic hash codes are not reverse engineered. In case a transaction data has an error, you can enter a new record for correction. In this case, it will show both the records. Therefore, there's no chance of errors or double entry. The second is chronological structure. Every block in a blockchain is stored in chronological and linear order, meaning they always attach at the end of a blockchain. And each block has a hash and the hash of the previous one. This fashion is followed throughout the blockchain that may contain thousands of blocks. Hence, it's challenging to retreat all the way back to change the records. Even if someone manages to alter a block, they will have to do it for all the other blocks, which takes a considerable effort, resources, computational power, and time. This gives users time to verify the block and find if it is compromised. The cost of such a hack could be prohibitive and, most of the time, unfruitful. The third is proof of work. Although hashing is an excellent way to mitigate tampering, attackers can still hack a blockchain using powerful computers to change a block and recalculate succeeding blocks and make the entire blockchain valid. To counteract this, blockchain uses proof of work, a mechanism to decelerate new block creation. It is a piece of complex computation that takes some effort to solve. And it also takes more time to solve the problem than verifying the results. Therefore, calculating the proof of work and adding a new block becomes way more challenging than changing the block and the rest of the blocks after it. This is how proof of work makes blockchains secure. The fourth is proof of stake. Proof of stake uses cryptographic algorithms to validate transactions. For example, in mining, validation is done by a selected validator depending upon the number of coins they occupy, which is called their stake. Users don't technically mine or get rewarded but forge blocks. Participants in the process gain coins, and those with more stake have greater mining power. It increases their chance of getting chosen as the validator. So, let's do a quick recap. In this video, we have covered 3 important points. The first is the types of blockchain, the second is how blockchain transaction works, and the third is how blockchain transactions are secured. The last series will focus on the advantages and limitations of blockchain, while also discussing use cases of blockchain and showing the history of blockchain. Guys, share this video with your friends and let's help more people understand what blockchain is all about. Don't hesitate to let us know what you would like us to discuss on this channel. We put in a lot of effort in creating each video. So, please like this video and subscribe to our channel, and don't forget to turn on your notification so that you can get notified each time we post our video. See you next time.